How's it going? Today we're going to do all things spheres, so surface area and volume of spheres. And without any introduction as to how these come about, I'm just going to kind of give you the formulas and we're just going to move forward. This is a surface area formula. In a sphere, all there is a radius. Everything's the same distance from the center of the sphere. It's a radius, and so the formulas only use the radius. Let's try a couple. It says, what is the surface area of a sphere with a diameter of 14 inches? Give your answer in terms of pi and also rounded to the nearest square inch. All right, so you're going to start off and you're just going to start with your surface area formula. For a sphere, it's 4 pi r squared. And we know the diameter is 14, so that makes the radius 7. So I'm going to have a 7 squared. So if I were to just leave it in terms of pi, I'm going to take my 4 times 49 and get 196 pi. If the directions say leave it in terms of pi, that's what you'd write. If you want to round it to the nearest square inch, it says, then go ahead and multiply that by pi, and you get 615.7, so I'd round that to 616 inches squared. Now, this one's a little bit trickier. It says, what's the surface area of a melon with a circumference of 18 inches? Now they're telling me what the circumference is. That's a little bit trickier, but ultimately, circumference formula is just 2 pi r. And if you know the circumference is 18, then I can solve this for r. I'm just going to have to divide by 2 pi. Now, you have to be really careful in your calculator on this one. When you take 18 and if you divide by 2 times pi, it's only going to divide by 2 and then it'll come back and multiply by the pi. So I usually do divide by 2, divide by pi. Or else you have to do some parentheses around your 2 pi. I get r to equal 2.86. Once I know the r, then I can go do my surface area formula and plug that value in. 2.86 squared. And so then I square that, take it times 4 and times pi. And I get 103 what's it say? To the nearest 10 square inches. Okay, that's an interesting way to round it. To the nearest 10 square inches. Let me write what I have. I have 103.13. All right, now when they say the tens, that's not the tenths. It's not this place. The tens place is right here. And so, because this is the ones place, this is the tens place. And the 3 would not round this up. So this is the last number that I'd really write, and I'd put zeros after it. So it ends up actually rounding down to a 100. I would write 100 square inches. All right, let's look at a couple volume problems. The volume formula has a fraction in it, so sometimes you'll have to leave your answers exact, so not just with a pi, but maybe also with a fraction. It says 4/3 pi, and then it says diameter 60, but it's supposed to be the radius cubed, so I'm going to do 30 cubed. What's the volume to the nearest cubic inch? All right, so I'm just going to type it all in, and I'm going to do 4/3, and multiply that by pi, multiply that by 30 to the 3rd power, and I end up with a volume of 113,097 is what it would round to the nearest cubic inch. Now we're doing volume. When you measure volume, it's in cubic inches rather than in square inches. Okay, now I kind of do a basic one, and then I do a little fancier one. So here's a little fancier one. It says the volume of the sphere is 5,000 meters cubed. What's its surface area? Okay. If you use your volume formula, the only variable there is your radius. So if you just put 5,000 in here, you can solve for that. All right, so the first thing I'd probably do is multiply both sides by 3/4. If you multiply by 3/4, that will go away. So in my calculator, I'm going to take 5,000. Think of your 5,000 as over 1. And you could reduce it, but I'm going to go decimal anyway. So I'm going to take the 5,000 times the 3, and then I'm going to divide by the 4. And that comes out nice. It's just 3750 equals pi r cubed. Now I could divide by pi. Still working on getting the r by itself. So then if I divide by pi, now I'm going to end up with a decimal here. And I have 1193.66 is equal to r cubed. Now this is the tricky part. You may or may not know how to do this in your calculator, but we need to cube root, not square root, but cube root both sides. And it kind of depends on your calculator. You're looking for something that looks maybe like this, like an x root of y or a y root of x, something like that. And what you do for most calculators is you'll put whatever the root is first, then you'll type this button, and then you'll hit this number. So I found it on my calculator. I'm going to hit, it's usually a second option, so I'm going to do a second, maybe second of your caret key probably. So I'm going to do second, or I'm sorry, no I'm not. I'm going to hit 3 first because I'm going to do a cube root. 3, and then I hit that button. And then I'm going to type in what my number is, which is the 1193.66. And that will cube root it. And that brings it down quite a ways. I've got a 10.6 is about what that would round to. Now all I've really found is the radius. Now I have to actually go find the surface area. So surface area is equal to 4 pi r squared. So that r, I'm just going to go ahead and erase that and change it. Fix my 4 because it's kind of ugly. All right, that's not better. And then 10.6 squared. 4 pi r squared. So take that number that's in your calculator and multiply it by 4 pi. And then your surface area is 133.3. Now this is area. We're back to area, so that'll be meters squared. Now that we're able to find the volume or surface area of different shapes, let's go ahead and do something kind of different. This doesn't have to do with spheres. This is just in general some relationships with volume and surface areas. So let's take a look at the volume today. And if you look at these different prisms, they're similar prisms. They've just been increased in size as you go. So you can look here with this 332 prism. Now it's a 664. So we have a scale factor of times 2 here. All right. Or if I go 332 and turn it into 996, that one has a scale factor of 3. So I'd multiply everything by 3. So what I want to do is I want to look at, okay, so if you take all the sides and double them, how does that affect your volume? Or if you triple them, how does that affect your volume? All right, so let's find the volume of each one of these. The volume of this one is the area of the base times the height. So it's going to be 2 times 3 times 3. Well, that would end up being 18. Okay, so let's remember the volume is 18. Here, the volume would be 6 times 4 times 6, which is 144. Now here's the thing. We just doubled the size, but that definitely did not just double the volume. That's way more than doubling the volume. And let's go ahead and figure the other volume, and then we'll come back and look at the relationship. So in this one, it's a 9 times 6 times 9, and I get 486. And again, I'm always referencing back to the original here. I'm referencing back to this one. I doubled the sides, but this way more than doubled the volume. I tripled the sides. This way more than tripled the volume. Let's look at how much that increased by. So I'm looking then at my scale factor to get from there to there. So I'm going to just type 144 and divide it by 18 and see what I get. Oh, okay, I got a times 8. Okay, what that really is if you look up here above, my scale factor was a times 2, and the volume is a times 8. What 8 actually is 2 cubed. 2 times 2 times 2. Okay, so if you double the sides, you cube the volume, or you multiply it by 2 cubed. Okay, so let's try that again. What if you go from the 18 over to the 486? So I'm going to take 486 and divide it by 18. And I get 27. So that's a times 27. But 27, you may not realize, is really 3 cubed. So let's look at this. If you double the sides, then you take the volumes times 2 cubed. If you triple the sides, then you take the volume times 3 cubed. If I quadruple the size, if I did a times 4, then I'd be taking this times 2 to the 4th. All right, so on this one it says, let me shrink this down a little bit. Okay. Okay, here's kind of that in a nutshell. Now, when we talked about surface areas, it had a squared relationship. So if the scale factor of one of these prisms to the other is A to B, whatever that is, the scale factor of their areas, their surface areas, would be A squared to B squared. And the ratio of their volumes would be A cubed to B cubed. Let me just throw some numbers at that so you see what I mean. If you had some sort of a scale factor, let's say that went 3 to 4, that was your scale factor from one shape to the next. Well, the area scale factor would not be a 3 to 4 anymore. It'd be a 3 squared to a 4 squared ratio, or a 9 to 16. That would be the ratio. Okay, if you had a volume and it started off with a 3 to 4 on the sides, the volume would have a ratio of 3 cubed to 4 cubed, or that would be 27 to 64 if you went to those numbers. Okay, let's try using that. Here's an example of two similar solids. You can see one's a little bit bigger than the next, but instead of them telling me the scale factor from one to the next on the sides, they've really told me the volumes. And if I know what the ratio of the volumes is, well, supposedly, to get from one volume to the next, I'd have some sort of scale factor, I'll just call it x, cubed to get from one to the next. Okay, so let's see what that would be. I'm going to take my 1331 and I'm going to divide it by 729. And I get some crazy ugly number. But I know that x cubed then would have to equal, and what I have is a 1.8257 and more and more. So now what I have to do is I have to cube root. Remember, we square root to undo squaring. We cube root to undo cubing to see what is x, what is my scale factor here. Now to do a cube root, different calculators do different things. You might need help on that, but there should be a button. It's probably like the second button on your up arrow, your caret, to do exponents. And so the way to do that, it probably looks like this. It probably looks like an x root of y or something like that. And so what this allows you to do is pick what root you want to do and what you want to do that root on. So I want to do the cube root of that ugly number that I have there. So the way you enter it is you choose the root first. So I'm going to type 3, and then I'm going to hit that button, so second caret, and then I'm going to type in my number. Now I actually would like to use that full number since it's so ugly and it didn't come out nice. I would take the cube root of that full thing. And when I do that, it actually comes out decent. It's 1.2 repeating. So that's my scale factor right there. That's how much I enlarged it by. Okay, let's try that one more time. It says, what's the scale factor of two similar prisms with surface areas 144 and 324? Okay, now remember, with area, it's not going to be the scale factor cubed, it's going to be the scale factor squared. So let's see what we had to multiply by. So I'm going to take 324, divide it by the 144, and oh, that's way nicer. So I just would have had to multiply by 2.25. So my x squared is 2.25. Now this is a little bit easier because now I square root. You should be more familiar with that. So I'm going to square root 2.25 to see what the scale factor is. Oh, that's way nicer. So my scale factor is a 1.5. That's how much I would have enlarged the sides by to have the area do that. Okay, just a little extra thing to throw in on this one. Go work on your homework. Good luck.